Hello, today we are going to be going through an introduction of chloride as an essential micronutrient in plants. The points we are going to be covering are the function of chloride in plants, chloride and soil properties, identifying chloride deficiencies, identifying chloride toxicity, testing for chloride in soils, and the management of chloride. Let's begin. The function of chloride in plants. Chloride was the most recent micronutrient discovered and is said to be involved in the function of stomatal opening and closing in relationship with potassium ions. Chloride has also been identified in the water splitting process during photosynthesis. Lastly, and some would say most importantly, chloride has been shown to suppress fungal disease such as leaf rust in wheat. Our next topic is the properties of chloride in soils. Chloride is a mobile nutrient and, like nitrate, has negative absorption with soil particles. Also, chloride ions are highly soluble in soil solution and are easily leached out of soil because of this negative absorption. Lastly, I wanted to mention that the areas that have the highest chloride availability are located near oceans that contain salt water. This is because the salt is evaporated and is supplied through rain. You can see these higher concentrations by looking at the map in the bottom left-hand corner, which has higher concentrations marked in brownish red, and the darker green areas that have a higher possibility of having chloride-deficient soils. This leads nicely into our next topic about chloride deficiencies. Chloride deficiencies. The symptoms of chloride deficiencies include chlorosis, leaf mottling, leaf tip wilting, and restricted root branching. In the picture on the left, you can see an example of leaf mottling in wheat with a mosaic pattern compared to a healthy wheat crop. In the right picture, you can see an example of grapes, which has strong chlorosis in the interveinal tissue. In contrast to deficiencies of chloride, there is also chloride toxicity. The symptoms of chloride toxicity include scorched leaf margins, reduced leaf size, stunting, and excess leaf abscission. In the picture on the left, you can see an almond plant with scorched leaf margins, and on the right, you can see the stunting effect on soybeans from chloride toxicity. In order to know if chloride is affecting your crop, soil testing may need to be done. For a chloride soil test, you will need to collect a sample to a depth of 24 inches due to its leaching ability. The soil test is done at a 1 volume of soil to 2 volumes of distilled water. Healthy crops usually contain 70 to 100 parts per million of chloride on a dry weight basis. As a disclaimer, because of chloride's recent discovery, not all soil testing facilities automatically test for chloride. You will need to ask them directly to test for it. After soil testing is complete, management is important. The most responsive crops to chloride management or mismanagement are alfalfa, broccoli, Brussels sprouts, cabbage, cauliflower, lettuce, oil palm, potato, small grains, sugar beets, and tomatoes. The most used and available chloride fertilizer is potassium chloride, although other fertilizers are also applicable. Today we discussed the function of chloride in plants, chloride and soil properties, identified the chloride deficiency symptoms, identified the chloride toxicity symptoms, and went over the basic chloride testing and fertilizer management. For further information on chloride or other micronutrients, contact your local university extension agent or research specialist. These professionals should have the most up-to-date information in regard to soil fertility, testing, and management. Thank you.
Created using Powtoon.